Yeah, so now we present the next set that we'll discuss in the next episode. So so problem one is basically we have two reals such as x minus y or x plus y is less than between 2 and 5, and then we will find x over y assuming it's integer.
I like this problem because maybe I'm the only one who voted in to have this problem on the set. Because when we have students take those problems from Math Prize for Girls, this is surprisingly hard for students because they all know when you multiply a negative number, you have to change the sign of your inequality. But they didn't have enough algebra experience about setting up what should they multiply. So it's a mess for them to analyze the cases. So that's why I like this problem and I want to talk about it, right? And we get number 2.
So number 2, we have a group of people, 13 of them like apples, 9 like blueberries, 15 like cantaloupe, and 6 like dates. And we also know that of all the people who like blueberries, they either like apples or cantaloupe, but not both. And of all the people who like cantaloupe, they either like blueberries or dates, but not both. So the question is asking, what is the smallest number of people that's possible in this group?
This is also come from HMMT a few years ago. And this problem gave all the contestants huge difficulties. When I was reviewing the problems on the second day, I think this is one of the hardest problem for me also. Okay? Well, one of our students find a good excuse for not solving it. He said, well, I don't know what a date is, so I cannot solve this problem. Okay, well, that's a good excuse. But, well, they make it so easy for you to say B, C, and a D, right? A, B, C, D. So that's clearly not an excuse. That's a good joke. But this is a good problem in the sense of asking about sets and their relation. Because of this problem, I ask the next question. Venn diagram. This is a very catchy word for many students when they are studying pre-algebra, algebra. They go home and they say, oh, I learned a Venn diagram today. Seems like a very fancy thing. But all the examples they see in the Venn diagram is basically what? 2 sets or 3 sets. And this tells exactly why this problem is hard. This problem has 4 sets, right? So it's a natural question. Why they never show us the Venn diagram for 4 sets, right? Why, right? So, you know, and why 4 sets make it so hard? Okay, so that's what this problem is about. Okay.
Number 4.
So number 4 is one of the in our Chinese contest. So it kind of resumes our discussion about the snake-like numbers. So we have 2 types of numbers. One is p-type, and one is q-type. So p-type, so they are both for-digit numbers. One goes down, up, down. No, q-type goes up, down, up. And we want to find what are the difference of these two types of numbers.
So technically, both of them are snake-like numbers, right? Yeah. So this is our final problem involving snake-like numbers, close the loophole.
And do they have to be distinct digits?
No, this time no. So they remove the one condition and ask a different question, right? So that's a good comment. It's about you have some ideas how many different ways you can ask questions.
Yeah.
Right?
And the last problem was, you said it's a very hard problem. We're trying to dissect a 1 by k rectangle, k is a real number, it's not an integer, into 2 polygons that are similar but not congruent. And here I think we should remind our students what are similar polygons. The angles must be
Corresponding angles
are congruent, and the ratio of the corresponding sides must be equal.
Yeah. So I would say this is a $5,000 question. The reason is, I think that year only maybe 3 students solved this one, and each of them won money on the usable because they are the top 3. So that's why at least each one of them won $5,000. So this is a $5,000 question. Right? Comparing to the $1 million question on the website, this is much easier.